Hello everyone, so welcome to this lesson. In this lesson, I'll be doing something different. I'll be comparing the SLA and the SLS process. I hope by now you understand each of the process, basic processing steps and advantages and disadvantages. So I think I want to start off this video with do you know? So most thermoplastics and photopolymers for industrial AM systems, AM means additive manufacturing, falls within the $175 to $250 per kg price range. So by contrast, the thermoplastic, a very technical term for just polymers or plastics, for the injection molding process, which is a conventional manufacturing process, are typically processed at about $2 to $3 per kg. So I think from here you can see that additive manufacturing is a very costly process. The price of its material is about 100 times more than the conventional plastics. So it's important to note that when you want to use polymer 3D printing, you have to print something that is worth the cost of the material and not just a simple plastic spoon or fork. So let's begin. So the first thing that I want to tell you about the both process is how are they categorized according to the ASTM standard, which is the American standard. So for SLA, it is under the wet photopolymerization category. And for SLS, it is under the powder bed fusion category. So just by the word wet photopolymerization, you can understand a lot about SLA in that it uses a vat, which is just a basin or a tank in which you put the resin inside. Photopolymerization means that the polymers are polymerized by photo, which is light, so it's a light curing polymer. So one of the main leaders in SLA technology is 3D systems. And for selective laser sintering, the category of powder bed fusion also tells you quite a bit about the method, in that SLS uses powder as a material and it is printed on a bed, and the fusion of these powders is by using a laser. So the leader in this SLS technology is EOS. So I also prepared a small table below that shows wet photopolymerization and powder bed fusion and what are the materials it can print according to my knowledge. So in wet photopolymerization, it's mainly a polymer kind of material, but in powder bed fusion, there are methods that can print in polymer, metals, and ceramics. So you can see that different categories of 3D printing can be actually quite diverse. So moving on, let me tell you on how the laser orientation and the distortion of the laser affects these techniques. So for SLA, there are two different laser orientations that you commonly see in this technique. Basically, it's either the bottom up approach, in which the laser is at the bottom and the part is built upside down, and the other method is the top down approach, which is the lasers on top and you just build the part from bottom up. So the benefit of the bottom up technique, in which the lasers below, is so that the resins can flow out of cavities in the model itself. So that's pretty good, because in the top down approach, if you build the part as conventionally as how other 3D printers build, if you have a cavity in your model, the resins will just get trapped in there, which is not that good. So also for such laser techniques, there can also be distortion, because most of the laser techniques uses an optical system to direct the laser. So in this case, you can see that if the laser is shining vertically downwards, then it'll be a circular shape, but if the laser is shining to the edge of the vat of resin, then the circle might be a bit elliptical, but this difference should not be too obvious. So let's proceed to the next one. So the next thing I want to tell you is the binding mechanism for the SLA and SLS process. For the SLA, it follows a photopolymerization process. So what this means is that there are photoinitiators, a kind of particle inside the polymer resin. So in which when you shine a light source, which is usually a UV light or a laser, this photoinitiator will give off a radical or an ion that would link all the polymers, the monomers together in such that they form a polymer chain. So that makes the polymer from the liquid form into the solid form because all the monomers are linked up together in a cross network so that they become a solid. So in the case of SLS, it is a powder sintering. So you can see in the diagram on the right, there are 4 powders at the cross section. When you shine the laser to it, the temperature of the powder will increase near to its melting point, maybe about 0.8 of its melting point, and then the powder particles will diffuse into each other, and then they'll form a solid part. So in the laser sintering process, you can see there are possible creation of pores because you are just sintering the powder and you're not like fully melting it. So these are the binding mechanism of these two methods. So the next thing I want to tell you is about the post-processing steps of both methods, because I think not many video mentions about the post-processing steps of 3D printing. So for SLA, when you finish the last layer, you have to understand that the part is still coated with a layer of uncured resin. So you have to remove this resin by using an IPA solution or other solution that I might not know. And then you put this part in the solution and then you send it to the ultrasonic, which is basically a basket which is vibrating at a certain frequency. So this allows the IPA solution to more easily remove the layer of resin. So once you remove that layer of resin, you can start removing the supports that you use in the SLA method. So this is important because you want to remove the supports before the polymer is like fully cured so that it is easy to be removed. And once you've removed all the support, it's time for post-curing. So the part is usually sent into another machine in which it is bathed in UV light so that it fully cures the part. So in this post-processing step, it could be also in a higher pressure or higher temperature, or probably in a different environment, because some polymer requires some special environment to be fully cured. So yeah. So now proceeding to the post-processing step of the SLS method. So when you finish the last layer of the SLS method, the part, instead of being in a resin, it is still in the powder bed. So there's still a lot of powder around your part. So as you take your part out, there can be still a lot of powder that's clinging onto your part. So you have to bring this part into another machine in which there will be a vacuum cleaner, a vacuum suction to like vacuum away all the powders that's sticking onto your part as best as you can so that you can recycle the powder. So once you have recycled as much of the powder, and there might still be some powder left at some very acute corner, then you bring this part into another machine in which you use a high pressure air jet to jet away all the remaining powder that might be even like sintered to the part, maybe partially sintered to the part. So that way you have your part which is a fully polymer and no other powder that's like sticking onto it. So the last step for SLS could be a coating. Either you might infiltrate it with wax or you might infiltrate it with epoxy. Why? Because in SLS, I think other than nylon being the very common material, people also use polystyrene for casting purposes. So that could be a possible post-processing step. So yeah, next. So we have come to the last thing that I want to tell you about SLA and SLS. So what are the benefits of them? So why would you want to use SLA? So basically SLA has a good surface finish. So you can see from the table below that SLA has a RA is the surface roughness average. So SLA has pretty good surface roughness as compared to the SLS, or maybe even the more commonly seen FDM method. However, when you compare the SLA to conventional manufacturing methods such as injection molding, investment casting, or precision machining, you can see that the surface roughness really lags behind and at most is comparable. But that's being said, SLA, one of the most common application of SLA is in casting of parts. So you use SLA to create the mold, and then you can pour your hot metal into it, and then you melt the mold to cast the part. So that is one of the main advantage of SLA. It has good surface finish. Another thing I want to add on this surface finish thing that I'm talking about currently is that for 3D printing, it is important to know that as you print at various angles, the surface roughness can differ. So that's why you see such a large difference in the RA value of each 3D printing part. It could be as good as 5 RA or 45 RA. So that's quite a big difference. So the benefits of SLS, why would you want to use SLS over SLA, for example, is because SLS has little to no support requirements. Why is this so? Because SLS is made in a powder bed of powders. So the surrounding powders acts as support materials for the part. So this is possible because you're actually not melting the powder, so you're just sintering the powder. So you don't have to worry about you don't have to worry so much about the surrounding powder sticking onto your melted pool of powder as you melt your part. So that is one of the benefits of SLS. So with little to no support, you can really create very intricate structures and very intricate assemblies that are all printed in one piece. So yeah. So with this, we come to the end of this video. So I hope you learned 5 new things about SLA and SLS technology. So the first thing I said was the process category. So how are they categorized in terms of ASTM standard? The next thing I told you about is the laser orientation of the SLA method and the possible laser distortion, whether your laser shooting directly below or your laser shooting at the edges of your printing area. Next, I told you about the SLA and SLS, how the binding mechanism, so how do they turn their raw material into the solid material. Next, I told you about the post-processing of a general brief post-processing introduction of the SLA and SLS method. Lastly, I mentioned about the benefits of the SLA and SLS method. So I hope you learned a bit more. So once again, I have to thank all the references that I use, and this video is mainly just a compilation of all the knowledge that is already created by a lot of people in the whole wide world. But my video is mainly just to consolidate these information so that I can promote 3D printing in some way. So yeah, thank you very much. See you.